Dear students, I am Ramesh, chemistry faculty from Vidyamandir Metric Higher Secondary School, Uttangarai. Let us discuss thermodynamics of cell reaction. Now, we are taking a galvanic cell. Galvanic cell. In a galvanic cell, the energy conversion is the chemical energy is converted into electrical energy. So, in a galvanic cell, the chemical energy is converted into electrical energy. And here we may produce the electrical energy in a galvanic cell. Now, the electrical energy produced from the galvanic cell is the total charge passed in a galvanic cell is multiplied with that EMF of a cell. So, we are taking that the total energy of a galvanic cell is equal to the number of moles of electron transfer from anode to cathode. So, here number of moles of electron transfer into E naught of a cell or E cell. So, here in a galvanic cell what will happen? The electron is transferred from anode to cathode. If it is zinc and copper couple, from zinc to copper the electron is transferred. Now, we are taking here how much number of moles of electron is transferred is nothing but charge transfer and is the multiplied with E cell. So, we may define the total energy of a galvanic cell, that is charge of electron and E cell. Now, if we are taken 1 mole of electron is transferred. So, here the energy is equal to 1 mole of electron transfer, 1 mole of electron transfer into E cell. If n mole of electron is transferred, so here n mole of electron transfer into E cell. So, here number of moles of electron is nothing but are taken as a charge. So, charge into E cell is equal to total energy. For the charge, we are taken, that is number of moles of electron transfer. So, here n mole of electron transfer into E cell. Now, charge of an electron. Charge of an electron is nothing but 1.602 into 10 power minus 19 coulomb. Charge of an electron. If you are taken, it is 1 mole. For 1 mole, we are taking that as a charge. So, charge of an electron for 1 mole. For 1 mole, we are multiplied with Avogadro number. So, 1 mole for 1 electron, it is 1.602 into 10 power minus 19 coulomb into Avogadro number 6.023 into 10 power 23. And here we may take, that is for 1 mole of electron transfer, it is nothing but, that is we may multiply or solving this, that is 96,500 coulomb. Then it is nothing but 1 Faraday. So 1 Faraday is nothing but 96,500 coulomb. So it is nothing but Faraday. So here we may take that n mole of electron transfer. For 1 mole charge transfer, we are getting 1 Faraday. N mole charge transfer. So we are taken here n moles of electron transfer is nothing but n Faraday. N Faraday. Now the total energy. So energy of a galvanic cell is nothing but n into F into E cell. Listen. Now we may take that it is energy transfer. The energy transfer from anode to cathode. So we may get the electrical energy. Then the electrical energy is used to do that any work. Transfer that will be converted into work. So the maximum work obtainable from the galvanic cell is considered as NFE, and we are taken here the negative sign. And here what about that negative sign? The negative sign indicates work done by the system. So here it is work done by the system. Work done by the system. So if we are taking the thermodynamics, work done by the system, the energy is lost. So that there is a negative sign. Work done on the system, then if it is a positive sign. So here the energy is lost when work is done, so that there is a negative sign. And according to second law of thermodynamics, second law of thermodynamics. So according to second law of thermodynamics, the maximum obtainable work is nothing but Gibbs free energy, that is delta G. So the maximum work obtainable is equal to delta G. Delta G. So maximum obtainable from the galvanic cell is nothing but minus NFE. Maximum work is equal to delta G is nothing but Gibbs free energy. So what is the Gibbs free energy? The available energy to do that useful work. So we may equalize here. So we are getting that is delta G, which is equal to minus NFE. So if we are taken that the EMF is positive, then the feasible cell is subtype. So according to feasibility, EMF should be positive and delta G should be negative. So we may rearrange. So what is it? Minus delta G is equal to NFE. NFE. So minus delta G is equal to NFE cell. NFE cell. So EMF of a cell is positive, then delta G is negative, then the cell reaction is spontaneous. If we are taken the standard condition, so what is the standard condition? We are taken at 25 degrees Celsius, the temperature is maintained at 25 degrees Celsius, and the molar concentration will be taken as 1 molar concentration. Then it is the standard condition of temperature and concentration. If we are taking the standard condition, then this delta G is nothing but delta G naught. If delta G naught and here minus NFE naught cell. NFE naught cell. So at the standard condition, delta G naught is equal to minus NFE naught. It is the thermodynamic relation to that EMF of a cell. So here the EMF of a cell is positive, then the delta G is negative, then the cell is spontaneous. Now we are taking the relation between EMF of a cell and that equilibrium constant. And according to thermodynamics, we are taking delta G naught is equal to minus RT ln K, that is equilibrium constant. You know that here delta G naught is equal to minus NF E naught cell. So instead of delta G naught, we are substituting minus NF E naught. So here minus NF E naught cell is equal to minus RT ln K equilibrium. Now we are taking both sides the negative, so it is converted into positive. So what is that? Here NF E naught cell is equal to RT ln K, that is equilibrium constant. So we determine that the E naught cell. So what is that E naught cell? Here that is RT by NF, then ln K equilibrium. Now what is the value of ln? So ln is equal to 2.303 log base 10. Is nothing but log. So we are introducing that log. So what is that? Here 2.303 RT by NF log K, that is equilibrium constant, and it is nothing but E naught cell. So we may take that the EMF of a cell is equal to 2.303 R is a gas constant and T is a temperature and N number of charge transfer or number of electron transfer and F is a Faraday into log equilibrium constant. If you know the equilibrium constant, then we may determine EMF of a cell at a standard condition. Now we may discuss Nernst equation. Nernst equation relates the E naught cell. So here it relates E naught of a cell, and concentration of the aqueous solution taken in galvanic cell. So here it will be relates the E naught of a cell and the concentration in that galvanic cell. Now we may take the galvanic cell. The reaction is X, A and Y, B. These are in equilibrium with that is L, C and that M, D. Now it is in equilibrium. Now we may take that the Q value of that equilibrium. And you know that Q value and that Kc value. What is that Q value? Under non-equilibrium condition, the ratio of product of concentration of a product to the product of concentration of the reactant, all those coefficients is raised to the power of concentration. So it is the ratio of concentration of C power L into concentration of D power M by concentration of the reactant, that is concentration of A power X into concentration of B power Y. If you are taking the Kc value, then it is at the equilibrium concentration. Now Q value is nothing but non-equilibrium concentration. So we are taking the Q value. And according to thermodynamics, we are taking the thermodynamic equation. So the thermodynamics equation delta G naught, which is equal to delta G equal to delta G naught plus RT ln, that is K is nothing but concentration of C into concentration of D divided by concentration of A power X and concentration of B power Y, and here L and that M. So delta G equal to delta G naught plus RT ln K. Instead of K, we are substituting Q. So Q is nothing but the product of concentration of a product to the product of concentration of the reactant. Now here delta G value is already known that. What is that? Here delta G is equal to NF E and delta G naught is equal to minus NF E naught. So we may substitute instead of delta G minus NFE. So here minus NFE is equal to minus NFE naught cell plus RT ln concentration of C power L and concentration of D power M divided by concentration of A power X and concentration of D power Y. So instead of delta G we are substituting NFE. Now we may take that here by both sides we may divide by minus NF. So both sides we may divide minus NF. Then what will happen here? That is E cell is equal to E naught cell. E cell equal to E naught cell minus what is that? RT by NF ln concentration of C power L and concentration of D power M divided by concentration of A power X and concentration of D power Y. So both sides we may divide minus NF. We may take that here, that is ln value. Then ln is nothing but here there is a ln. So ln is equal to 2.303 log base 10. So substitute the ln into log. So what is it? Here E cell is equal to E naught cell minus 2.303 R into T by NF log concentration of C power L into concentration of D power M divided by concentration of A power X and concentration of D power Y. Now we may do the values of R and T and N and F. And you know that R value, R is equal to 8.314 gas constant. And here temperature at 25 degrees Celsius. So we are taking in Kelvin, it is 298 Kelvin. And that is Faraday, 1 Faraday is equal to 96,500 coulombs. Now substitute this value in this equation. Then what will happen? Here E cell is equal to E naught cell minus 2.303 into R 8.314 into T is 298 divided by, that is M is number of moles of electron transfer and Faraday it is 96,500 coulomb into log concentration of C power L and concentration of D power M divided by concentration of A power X and concentration of D power Y. By solving this we are getting, that is E naught cell minus 0.0591 by N, that is log concentration of C power L and concentration of D power M divided by concentration of A power X and concentration of D power Y. Now it is the simplest form of Nernst equation. So it is the Nernst equation. Okay, here the Nernst equation problem is given, and here the cell, that is Cu becomes Cu2 plus and concentration, and Fe3 plus becomes Fe2 plus and its concentration is given, and the E naught cell of Fe3 plus and Fe2 plus and E naught of Cu2 plus and Cu is given. Now we may take that the solution. First we may find out the anode and the cathode reaction, and here it is anode and here it is a cathode. And you know that anode is always oxidation takes place. So which one get oxidized? Here Cu become Cu2 plus 2 electron. So it is anode oxidation. Now we may take that at a cathode. cathode, reduction takes place. So we are taking that it is a cathode. So here Fe3 plus is converted into Fe2 plus. And here 2 electron is transferred so that it should accept 2 electron. So we are taking 2 Fe3 plus and 2 Fe2 plus. Now we may take the overall equation. What is the overall equation? Here Cu and 2 Fe3 plus and gives Cu2 plus plus 2 Fe2 plus. Now it is the overall equation. Now we want to find out from that inert cell, we want to find out the inert cell, the overall inert cell. So the inert cell is equal to E naught of oxidation at anode plus E naught of reduction at cathode. Reduction at cathode. Now we are taking oxidation at anode. What is that oxidation? Cu becomes Cu2 plus. But here the value Cu2 plus becomes Cu. Then here it is the reduction potential. We want to get the oxidation potential. So just change the sign. So what is that? It is minus 0.34. Minus 0.34 and here reduction potential. Here what is the reduction? Fe3 plus become Fe2 plus and here what is the inert value? Fe3 plus become Fe2 plus. So it is the reduction potential. Cathode is reduction takes place. So as it is 0.77 volt. Now by taking this it is 0.43 volt. By 0.43 volt it is inert cell. Now is equal to E naught cell minus 0.059 by N, that is log, and concentration of a product and concentration of the reactant. What is the concentration of a product? Here it is the product Cu2 plus and Fe2 plus 2Fe. So what is that? Here it is Cu2 plus and Fe2 plus, so it is Fe2 plus power 2 divided by, and the reactant, what is that? Here Fe3 plus power 2. Now we may substitute all the value. Inert cell value is 0.43. So what is that? Here 0.43 minus 0.059 by N value is 2. Number of electron transfer, it is 2. That is log Cu2 plus value. So Cu2 plus concentration is 0.25. So it is 0.25 molar. And Fe2 plus concentration, Fe2 plus concentration is 0.1. And here that is Fe3 plus concentration, so it is 0.1 whole square, and Fe3 plus is 0.005 whole square. Okay, now we may take here 0.43 minus 0.059 by 2 and log, it is taken as, that is 25 into 10 power minus 2, and it is taken as, that is into 1 into 10 power minus 2 divided by, we are squared, so here it is 25 into 10 power minus 6. So we may calculate this, it is 0.43 minus 0.059 by 2 and log, here 25 and 25, so it is cancelled. So we are taking, it is 10 power minus 4 and minus 6, so 10 power plus 2. Now, what is it? It is 0.43 minus 0.059 by 2 and 10 log 10 power 2 is nothing but 2 log 10. So, log 10 is 1. So, it is taken as 1. So, 2 cancel. So, we are taking 0.43 minus 0.059. So, we may get the answer, that is 0.37 volt. 0.37 volt. So, we may get it the answer. Thank you.